You may have seen a train, the first compartment of the train, where the driver sits and moves the locomotive. And after that, you might have seen different coaches of different number of length. You may have seen goes a train up to infinity. Well, not practically, but we can show that by dot 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 infinite train. The point is that you see there is the first compartment which is pretty different from the other remaining compartments behind the train. So it's like a head of the train which is moving on a platform. What? Not platform, on the railway track. Yeah, the train moving on the railway track with the head at the first of all the compartments behind it, and they all are connected with some sort of link joints. You see, and a train can move only in forward direction. If we talk about a normal train, not a bullet train or ice train or a jet train, whatsoever. So the idea is here is a head node and some child nodes, or you can say next nodes, because head is first. After that, we have the next node, the next node, the next node, the next node. Why I'm saying it as a node? Because when you use this same philosophy for computer science, you get up and data structure which we call as a linked list. Actually, this is also a kind of linked list structure, but just for understanding purpose, a linked list is a sort of structure which have a head node and then attached to it some next nodes which all are have their links with each other, and it only has a one-way direction like this train. Okay, so if we talk about very general case, or what a linked list sort of do, uh, before do, let's understand what linked list really you know mean of its structure in the context of memory, because these all head next, these are just conceptual things just to get a better visualization of a linked list structure, but in reality there is nothing like such. So we just focus on this is for the purpose of just to get familiarity. Okay, now let me just quickly make some memory. So this is our computer memory, which is like of stack and of heap. So it stores some values over here. Let's say this storing 203 value in it, and the address of this field is, let's say, 100. So the address of this field in the memory is 100, which is storing 203 memory. And let's suppose we have some other locations also. Let me make them quickly. Okay, let it be 150. Let me make one more location. Let it be this one, and let it be 170. Okay, and they also have some data. Let's just put the data here. Let's say 200, or say 2000, this field have 2000 data, and this field say 10. Okay, so you already know the structure of a memory. It's kind of stack with some address and some values at that place. So what's the benefit of a linked list over an array? And now what's an array? Oh, what a damn thing I've chosen. You don't know array? Wait, let me make a structure for you. So array in memory is like of continuous memory blocks, and these continuous memory blocks are predefined by the user, or dynamically can also be defined. But the thing is, if this field is at address 100, then this will be at 101, then this will be at 102, this will be at 103. Now obviously if it depends on the data type, for example if you choose integer, it's of 4-bit, so this whole will be of 100 to 104. But just to explain you, if this is 100, the next will be 101, the next will be 102, the next will be 103, and so on. The point is that they all are contiguous in nature in the memory. It's not like that it will be say 200. No, the address should be 101. This is the main problem, because we have to make a fixed memory for this. Let's say if we initialize our array with the size 4, which is in this case, so we can only insert 4 elements to it. But let's suppose if we don't insert any element to the last of it, so this place will remain empty. So what could be the problem with this if it remains empty? Think of it. You don't have a brain? Okay, let me tell you. If this remains empty, but our array has already taken up the spaces for this as a whole is our array. So this piece of memory, although it's free, it can't be used up by any other extra variable. So it's kind of like moving in the memory with free space, but of no use because we haven't assigned any value to it. In case it can be used for other variable storage, but as it kind of like bounded into the array. You see, it's kind of bounded into the array, so it can't be freed up. So to mitigate this problem, the linked list is a very good solution. Now let me just tell you how it works. And it also don't need to be specified its length. It can allocate as many nodes as it wants dynamically. Let's suppose we have, let's just use these, but just to show you, I'll make a separate diagram for this. Okay, let's suppose we have this, we have this, we have say, yeah, okay, here, say this one is here, let's put it here, and let's just copy this one also here. Now let's just change their addresses. So let's say it's 200, it's say 205, it's say 305, it's a what we call it, let's say 310, and let's say this is a very big size, 500. Okay. So now what a linked list structure will look like, I'll show you that. You see, these all are places in the memory, at different locations. Okay, like this, 100 is here, 150 here, 170 here. So here we have some 200 address, some 205, 305, 500, and 310 address. So how a linked list will be connected is, let me show you. we will have a link between this first one, and let's just say we have link between, yeah, this one. And let me just make some links, and then I'll show you how it can even mitigate the thing. Okay, let's just copy this and say now this will point to, say, this one. Okay, and now let's just again paste that, and let's say this will point to this. Okay, you got it. So what you can see here is, did I make it wrong? Yeah, this should not be like this. This should be like this. Yes. So now you'll see that we have a structure. So this list will now have 200, 310, 305, and 500 addresses. And yeah, these are addresses, not values, so don't confuse, just locations. But you see, we have 125, oh, 125, it's 205. This is in between 200 and 500, or 200 and 305. So it's kind of like this between 100 and 102. This is 101. So in the linked list, in the array case, if this was empty, so we can't use it. But let's suppose this is empty, so we don't care about it, because it doesn't matter if it's empty or not, because in our linked list it is not connected. So our linked list is like this way. So you see, these are different places in the memories, but are connected via their addresses. Understand? So if we suppose, let's say, give it back, it's what was that number, 101, and this was 103. So if we display this as an array, as we normally do in our notebooks, we'll just simply do what? We just simply make it as, let's say, 100 and 100, 101, 102, 103. So this will be its structure look like. And for this case, the structure will be, let me just copy it down. Yeah. So for this, the structure will be, I think you got it, 200, 310, 305, and then at last we'll have 500. Okay, so, but instead of like this link, it will have like this link. So this address is connected to this address, and this address is connected to this address, this address is connected to this address. So we don't have to use this 200 and let's say 5 address, because we don't require. We are just using arbitrary values, addresses of memory pieces to store our elements. So it's not a contiguous order of listing the elements, storing the elements like an array. So you see, in this way, if there is any free space between the addresses of the list, it can be used by some other variable. But in this case, if let's suppose this was empty, so there is no chance that any other variable can fill its value here, because computer memory will treat array as a whole, so it will not give this as a single entity to any variable. But in this case, if we, let's suppose we want to put here the value of x, say 10, no, it's not 10, this is 10, so it's very easily be putable that x equals to 10. So it will not affect our linked list structure. So that's why linked lists are very important. Storage management, memory management, it's very effective to use linked list. Now in further videos we'll discussing about the types of linked list. There are basically of three types: singly linked list, doubly linked list, and circular linked list. So for that, please watch further videos. Thank you.